What's up, everybody? This is Danny Mathematics again. Today I want to go over example 3 of how to add and subtract negative and positive fractions. How to add and subtract negative and positive fractions. And I already put our little key tools up and information that we need, guys. I always draw the tic-tac-toe tool because, once again, whenever we have the same signs, we add, right? So if we go in a diagonal, if I had two positive fractions, I'm going to add at the end. If I have two negative fractions, I'm going to add at the end. But if they have opposite signs, we subtract. So if I have a positive fraction and a negative fraction, I'm going to subtract. If I have a negative fraction and I have a positive fraction, I'm going to subtract. Okay, so remember, same sign, we add. Same sign, we add. Opposite signs, we subtract. Opposite signs, we subtract, okay? So either you can just remember that just from memory, or you can utilize the tic-tac-toe tool to help you, okay? So in this particular case, guys, I have the fraction of 4 4/5 minus a parentheses negative 3/10. Once again, I have 4 4/5 minus a parentheses negative 3/10. Now, remember, guys, I was talking about same signs we add, opposite signs we subtract. Here, guys, the reason why the second fraction is in a parentheses is because we're trying to figure out what it's telling us. It's telling us that we're subtracting a negative, okay? We're subtracting a negative. So are we really subtracting? If we're subtracting a negative, we're going to figure it out, okay? So once again, a subtraction sign is synonymous with being negative, right? And a sign that's associated with the fraction in the parentheses has a negative sign associated with it, right? So remember, guys, same signs we add, opposite signs we subtract. So since those signs are the same, guys, what we want to do is we're going to cross them out and we're going to put a addition sign. Because remember, same signs we add, right? So those two signs go away, and then and we substitute it for an addition sign, okay? So now all we're gonna do is just bring everything else down as is, okay? So once again, I still have 4 4/5. And I no longer have the negative sign associated with the 3/10 because remember, both of those negative signs change to this positive sign. So I'm just gonna bring down 3/10. So now I have 4 4/5 plus 3/10, right? So once again, what I need to realize, guys, is the signs that are associated with each fraction. I automatically know that this 4 4/5 is a positive because there's no sign in front of it. So I can just go ahead and put a positive sign in front of it, meaning that it's positive. And the sign that's in front of this 3/10 is a positive sign, right? So of course, as we circle both, we can clearly see that they are both negative. I mean, they are both positive, my bad. They are both positive, meaning that in order for us to solve this, since they have the same sign, we're going to add. Since they're both positive, we're going to add them, okay? Now, let me just rewrite them going again. I'm just gonna rewrite them again. Now we have a dilemma. The dilemma is both fractions are not in position to actually be added together because they do not have the same denominator. The same denominator, which is the bottom number of the fraction, or the bottom part of the fraction. If you notice, 5 does not equate to 10. So they do not have the same denominator. But what we can do is we could manipulate one of these fractions, or if not both, to where both of them have the same denominator, okay? Now, 5 is not 10, but I know for a fact if I multiply 5 times 2, I will get to 10. So if I'm willing to multiply 5 times 2 so it can equal 10, then I have to do that to the numerator of the fraction as well, okay? So I'm gonna do 4 times 2 and I'm gonna do 5 times 2 so I can manipulate this fraction to where it has a denominator of 10. Okay, so once again, I still have 4, a base of 4, and now I'm going to manipulate this. So I have 4 times 2, which is 8, and I have 5 times 2, which is 10. Okay, and once again, I still have a plus 3 over 10. Now, guys, since they both have the same denominators, we're good. All we need to do, guys, is just add the bases or the whole numbers together and then add the numerators together, okay? So remember, guys, we do not add the denominators. The denominators stay the same. So I already know that it's gonna be over 10, okay? Now, I have a base or a whole number of 4, and I don't have a whole number that's associated with 3 over 10. So there's actually an imaginary 0 right here, okay? So it's gonna be 4 plus 0, which is still 4. Now, all I need to add, guys, is just the 8 and the 3. And I'm gonna make them be red so we can clearly see. All I need to add now, guys, is just the 8 and the 3. So 8 plus 3 is 11. So now I have 4 and 11 over 10, right? But this fraction is not in its truest form because it's improper, okay? I want to change it to a proper fraction because I need the numerator to be smaller than the denominator, right? So what we need to do is, guys, we need to divide the numerator, which is 11, by the denominator, which is 10, to see how many wholes is going to come out, right? Because 4 is a whole number, right? And I know that if it's 11 over 10, then it's another whole number that I need to add the 4, okay? So how many times can 10 go into 11? Only once, right? Because 10 times 1 is 10. And then we have a remainder of 1, right? Now, our remainder of 1 is our new numerator, which is the top part of the fraction. And this 1 right here is going to be a plus 1 to our base of 4, or our whole of 4, okay? So now, here's how it's going to look. I have 4 plus that 1, right? 4 plus 1. And then, of course, I have a new numerator of 1, and the denominator still stays the same, which is over 10, right? So remember, I have to add that whole 1 to the 4, right? So 4 plus 1 equals 5. So now I have 5 and 1 over 10. 5 and 1 over 10, okay? So once again, guys, this is how we solve or how we add and subtract negative and positive fractions, okay? So once again, our answer is 5 and 1/10. All right, I will come out with more examples showcasing how to add and subtract negative and positive fractions. Thank you.